Your autonomic nervous system is also your automatic nervous system, in that it runs in the background and controls all kinds of things so you don't have to think about them. So it's autonomic motor neurons that innervate smooth muscle, cardiac muscle, and glands, visceral sensory neurons, so that you have sensation from your hollow organs, and integrating centers in the central nervous system. There are two further subdivisions within your autonomic nervous system: the parasympathetic, or rest and digest, nervous system, and the sympathetic, or fight or flight, nervous system. And it's an ongoing balance between the two systems. If you're awake, which I'm assuming you are if you're watching this lecture, you're a little bit more on the sympathetic side. If you're completely asleep, just sitting there in your chair, then you're definitely in parasympathetic mode. The autonomic nervous system is a two-neuron chain. If you remember, when we talked about somatic motor systems, we talked about a neuron, an alpha motor neuron in the spinal cord that went out and innervated a skeletal muscle in the periphery, and it was one neuron with one axon that went to the muscle. In the autonomic nervous system, it's a two-neuron chain, in that there is one neuron within the central nervous system, either the brainstem or the spinal cord, which then sends an axon out to a ganglion. And in this example, we have the sympathetic chain ganglion. With the cranial nerves, there are specific ganglia associated with the different cranial nerves. So and then those ganglionic neurons are the ones that send the axon out to the target. So somatic, one neuron, one axon out to the muscle. Autonomics, both parasympathetic and sympathetic, a two-neuron chain. Neuron 1 is in the CNS, either the brainstem or spinal cord. That neuron synapses with the neuron in a ganglion, which is pictured here. The ganglionic neuron is then the neuron that sends its axon to the target, which is going to be smooth muscle, cardiac muscle, or a gland. The sympathetic nervous system is also termed the thoracic nervous system to some degree, because its first neuron in the chain, the CNS neuron, lives within the spinal cord between T1 and L2. The sympathetic nervous system is responsible for increasing respiratory rate, increasing your heart rate, increasing your blood glucose, dilating your pupils, and relaxing your gut. All of these responses are there to help you fight or flee. So run away from the tiger, or turn around and fight with the tiger, which I wouldn't recommend. But think about, you need increased blood glucose because your muscles need more energy, dilated pupils, you want more light to come in, so it's like all the better to see you, Grandma. So you have more light coming in so that you can see the danger in front of you. The parasympathetic nervous system is cranial and sacral, in that the preganglionic neurons for the parasympathetics are within the brainstem and in the sacral part of the spinal cord. And this is our rest and digest system. So you have a decreased respiratory rate, decreased heart rate, decreased blood glucose because you're on the way to storing everything that you've just digested, and constricted pupils because, like I said, it's the rest and digest, so the going to sleep. You want less light coming in, and busy digestive system, busy gut, lots more peristalsis because you're digesting. So what would I like you to know about these basic components of the autonomic nervous system? So what are the two divisions, the two subdivisions of the autonomic nervous system? What are their basic functions? And then what effects does each of these subdivisions have on heart rate, respiratory rate, gut activity, blood glucose, and the size of the pupil? If you understand all of these concepts, then you're ready for the assessment.